So in this video, we will learn to work with a tool named Central Future. We will get back to this tool. So first, we're talking about this calculation of centers. The distribution of features in a dataset has many characteristics that can be helpful for the analysis. One of these characteristics is the calculated center of the distribution. Centers can point out trends in movement, the best location to service all the features, or the feature that is shortest distance from all the features. Sets of features that are spread over an area are said to have a geographic distribution. Sometimes have a regular distribution, such as trees planted in a garden, or can be a random distribution, such as the locations of crimes, etc. This kind of tools help to determine the statistical probability that the patterns and relationships rarely exist versus being randomly occurred. There are different types of centers in general in statistics and mathematics. First of all, there are three main types of centers. First is the mean center, second is the median center, and the third is the central feature. So the first type is the mean center. The mean center is calculated by finding the average of the x values coordinates and then finding the average of the y value coordinates. So the resulting xy coordinates pair is the mean center. So this mean center, can be helpful in determining the movement of a set of data over time, such as the migration of animal herd. Second is the median center, also called the center of minimum distance. This function finds the xy coordinates pair that is the closest to all the rest of the features. This function has a built-in geographic weighting which does not occur with the mean center. So if you're familiar with statistics, I think you understand what the median means. So if mean is just arithmetic average of all the values, median is located in the center of a sequence of values, from the lowest one to the highest one. The third type of central is the central feature. This function identifies a single feature that has the lowest total distance to all other features. Note that the central feature must occur at a location that has a feature, unlike the median center, which has occurred at an xy coordinate location. For instance, this tool can be used to find the school campus that is most accessible to all other others for a district-wide meaning. So this is our map for a certain region. Let's name it Battalion 2. So this territory has this alarm. This area has alarm territories. We can see it here by turning on and off alarm territories. So these are the major roads, and these are the battalions. Just the area, and these are the active stations and proposed stations, and also calls for calls for service for 5 alarm stations for the February 15. So let's imagine that we want to calculate the mean center for each alarm territory. First, we will use this mean center to calculate it using the optional case parameter. We will use a station field for the case value, causing the tool to calculate a mean center for each unique value in the station field. So first, let's look for the mean feature, mean center. So it is located in spatial statistics. We can just take a look, fast glance to it. Identifies the geographic center or the center of concentration for a set of features. So let's say that there are a set of features randomly located, and it it will identify the mean x and mean y values, and this locate this it shows its coordinates. So input features call centers for February 15. Output feature class, let's say battalion 2 mean centers. Save. It's a case field. Case field is a station. We can take a glance fast. So we have see here there are many attributes of this table. Commands. See that the actual calls, medical assistance includes incidents where the medical assistance is provided. Dispatched and cancelled, and the incident cleared or cancelled prior. So these are descriptions: medical assistance, cooking fire, confined to container, defective elevator, no occupants, medical assist, etc. It's PN. These are the information, the time, district, address, incident number, station, etc. So we will need this field. Let's click OK and see what we have. Let's change it to yellow. So these are the main locations for stations. We can, by the way, we can try to symbolize stations. So there are several stations here. Changing the color. So these are our stations. We calculated, see that the mean of each station. We can go to the attribute table. These are the mean coordinates for station 1, station 2, 5, 8, and 14. Let's compare. So this is the station 1. Where is it? Should be this one. Yeah, it's station 1. We can change, for instance, to black to see how station 1 looks. So these are the station 1, and for mean location, mean XY coordinates is here for station 1. This probably station 2. Yeah, it's station 2. We can change it to this one. So for station 2, mean XY coordinates are here. And these are the active stations. See, so this one is more or less far. We can just even see the distance we have here. So measure tool. Let's measure the distance between the active station and the mean station location. So it's fairly close, 570 meters. This is even closer than it's actual. We can just zoom in. So it's very close. It's in meters. Planar distance meters, yes, 225. This this is also very close to each other. 500 meters. So see that the difference between the active stations, mean location for the alarm territories, active stations for alarm territories is close to the mean location of fire calls. Fire calls for stations. For instance, these are the fire calls for station 2 for February 15. For instance, these are the locations of this, for instance, commercial buildings or houses or real estate which had this fire incidents and called for station 2. This is station 2, and station 2 send its fire engines to work with fire, whereas the mean location for this fire for this alarm territory probably for the February 15 will be best here, but if we will analyze for the whole year, it will be much bigger territory. Probably a mean location will change. It will be also something probably around. So we don't know which is the best location for the alarm territory. For this alarm territory, just we cannot make a final conclusion based on only February 15 calls. So imagine that this battalion 2 government wants to relocate the battalion head office. The new location must be confirmed as the most centrally located for all the stations in battalion 2 before the fire chief will approve the money. So battalion 2 includes stations 2, 5 and 1, 2, 5, 8 and 14. Next to we will choose stations and run this central feature tool, which will find the most central located for all the stations. So first we will go to selection, select by attributes, active stations, battalion 2. So these are the active stations. We don't need this one. These other stations we're running for the battalion 2, this area. And now it's central feature. So we can take a fast glance. Identifies the most central located feature in a point, line or polygon feature class. See, it slightly differs from this mean center. It defines the most central located feature in a point, line feature class. So active stations, we can choose this battalion 2 central feature. Okay, so we will, here are two options. First is Euclidean distance, the straight line distance between 2 points. We don't need this. We will choose the second option, Manhattan distance. The distance between 2 points measured along axis at a right angle, city block, calculated by summing the absolute difference between the x and y coordinates. So I can read again. The distance between 2 points measured along axis at right angles, city block, calculated by summing the absolute difference between the x and y coordinates. So we can click, so these are the weight, the numeric field used to weigh the distance in the origin distance. Now we don't need this. Self-potential weight, the field represents self-potential, the distance or weight between the feature and itself, and case field, we don't need this. So let's compute. So this is our result. See that only one feature, battalion to central feature. We can go and see the address, X and Y, battalion. So we can see that we can change the, for instance, symbology, make it, for instance, a star, red one. Where is it now? I think I need to do it bigger. See, it's actually, no, I can probably need to change the color for, let's make it purple, dark purple. So this is a central feature. So it's overlaps with the second station. So the best is the closest to all the stations, weighting this sum, weighted sum, the most central located feature. When we compare all the stations, is a station 2. So the central chief of the battalion can be located for station 2 that is most convenient to other stations. So note that this doesn't mean that the chief will be any closer to expected all the causal services, because these areas are really far from this station 2. So there can be other examples, real life examples, how these tools can be used. For instance, police department may map crime locations by type and calculate the mean center to determine where to focus a task force. Or for instance, a company may look for a new office location based on the mean center of its customers or employees, etc. So these tools are very helpful for GIS statistical analysis.